Good morning, good afternoon, good evening, everyone, depending on where you are. I understand we've got a large number of attendees from various parts of the world, so welcome. Thanks for joining me for today's webcast on behalf of O'Reilly and 26 New York. I'm very pleased to be able to present this session on programming the new beyond relational features that have been added to the SQL Server product with the release of SQL Server 2008. I will mention at this point that everything that I'll be demonstrating works with SQL Server 2008 and does not require R2. And in addition to that, it works with every edition of the SQL Server engine, including the Express edition. So all of the features that I'll be presenting today work with the free edition, SQL Server 2008 Express edition as well. A little bit about myself. I'm a principal consultant here with 26 New York, located, of course, in New York City, where we are a Microsoft Gold Certified partner and have distinct practices across the Microsoft stack in BizTalk, SharePoint, and of course, lots and lots of .NET development with SQL Server. I do lots of speaking and writing as well. My email address appears on this slide, as well as my blog address. And then again, on the last slide of the deck, along with some other contact information. And for now, that's well more than enough about me. It's time to get started by taking a look at today's agenda. And we'll be diving into these three new features that fall under the category of Beyond Relational. Beyond Relational is actually a key release theme for Microsoft in SQL Server 2008. And they actually started exploring this area with the XML data type that was introduced in SQL Server 2005, which gives us semi-structured XML data inside of our relational database, and is now an area pursued much more aggressively by Microsoft in SQL Server 2008 with the addition of these three new features, which we'll be examining in turn. Starting off with native file streaming using the new FILESTREAM feature. Let's begin with that. Well, this is not a new problem. So we, of course, in our relational databases, we store tables and columns as structured data, but increasingly we have to deal with more and more unstructured data in the form of blobs or large binary objects that usually represent either JPEG images, AVI files, email messages, Word documents, spreadsheets, PDF files, and the list goes on. And there's a proliferation of this binary data that's falling into our laps as database developers, and increasingly it is becoming our challenge to manage all of this. Now, as I said, this is of course not a new problem, and to best appreciate the new FILESTREAM feature in SQL Server 2008 is to first examine the choices that we've had until now for dealing with this. And the first is to store blobs in the database. And to do that, you use the var binary max column. And you may be familiar with doing this kind of thing with the image data type. You should no longer continue using the image data type. That's been deprecated and will actually be removed from a future version of SQL Server. It survives still, but you should use the var binary max data type. And you get a number of advantages when you do that, when you store blobs directly inside that column. The first of which is integrated management, right? You have a single database that contains all of your data, and a single backup of that database includes your structured and unstructured data. Everything's transactional, meaning, of course, if you begin a transaction and then perform some updates, if you roll back that transaction, any blob updates will get rolled back as well. It's simpler to program against this model. You don't have to do anything special to get at the blob data. It's there in the column. So there's all those advantages, but then there's the one big disadvantage, and that's the last bullet point here, right? That is to say that unless your blob requirements are very modest, that is, you have very few of them, or they're very small, or both, unless that's the case, you are really pushing the envelope, if you will, by pushing all of this unstructured blob data into your structured tables. You will bloat those structured file groups. Query performance will degrade terribly to the point where this option is prohibitive from a performance standpoint, despite all of the advantages that we enjoy otherwise. So if our blob requirements are heavy enough, we'll definitely need to take those blobs outside the database. Relational data belongs in tables. Files belong in the file system, right? So let's do it that way, store the files in the file system, and in our relational tables, rather than containing the entire blob, we merely store some sort of reference or a path to where that blob data lives, and thereby address the performance concern of not clogging or bloating our structured file groups with unstructured binary data. That just gets in the way of our queries, right? So we definitely addressed that concern, but now we've got a number of new challenges here because we have physically separated this data out from the database. SQL Server, of course, has no awareness of the files in the file system. If you back up your database, your backup is incomplete unless you back up the file system as well. So now that's another administrative burden. It's also more complex for you to manage and program against this model because it's up to you to keep track of where the blobs live and to manage all of that because the coupling between the structured data in your database and the unstructured data in the file system exists only at the application level. SQL Server has no awareness of the data in the file system, and perhaps worst of all, that means it's not transactional, such that if you begin a database transaction and perform some updates to your database, as well as updates to the blobs in the file system, I don't think anybody here expects that rolling back that database transaction will in any way undo the changes that you made in the file system. Certainly not. So there are a number of challenges either way you go, and the new FILESTREAM feature in SQL Server 2008 has been designed to address all of these concerns and give us actually the best of both worlds and then some. And what I mean by and then some is really the second part of this, so we're going to split this up into two parts. We're going to start with the basic FILESTREAM abstraction. And the first thing to be clear about, which many people I hear misstate this, is that FILESTREAM is not a new data type in SQL Server 2008. It is an attribute. You continue using the var binary max data type as you have in the past. The same data type that you've been using to store the blob data in line in your columns right alongside the rest of your structured data. But by merely appending the FILESTREAM attribute, you enable the FILESTREAM abstraction, if you will, over that column such that from your perspective it looks, works, and feels, smells the same as it did before, but behind the scenes, SQL Server is going to store the data in the file system where it belongs. So you don't have the performance concern, but you gain all the benefits of integrated storage of your blob data. Right? It's simpler for you to program now because SQL Server is going to manage all of the references between the relational tables and the blobs in the file system. No extra effort is required on your part as a developer to deal with that. And perhaps most important of all, to some people anyway, that we get full transactional capabilities because the NTFS file system is a transactional file system, and SQL Server integrates with that file system so that when you begin a database transaction and you start updating some data that includes blob data that's designated as var binary max file stream, which is stored in the file system, SQL Server will automatically and transparently initiate a file system transaction over that blob data such that if you roll back the database transaction or for any other reason that database transaction fails to commit, SQL Server will automatically and again transparently roll back the NTFS file system transaction for you. Right? So we need to enable FILESTREAM before we can use it. That's true of almost all features in SQL Server 2008 as part of the secure by default strategy. It's a little bit more involved for FILESTREAM because it needs to be enabled at two levels. I don't want to get bogged down to those details. I really just want to start using FILESTREAM. I've already enabled it at the Windows machine level and at the SQL Server instance level. And we'll talk about these settings in a moment. The default setting is disabled. The next setting, which enables it for T-SQL access only, will be our first part of our demo, and then we're going to look at file system access in the second part of our demo. So the way that you create a FILESTREAM database is just using the ordinary create database statement like you see here, with this new file group contains FILESTREAM clause inside of it, pointing to a folder that you want SQL Server to create and manage. So this photos folder in this example is a folder that does not yet exist, just like the MDF file does not exist and the LDF file does not exist. The DB folder has to exist and should be able to be empty and ready to hold these files, as well as the new photos folder. And that gives you the integrated management. So from SQL Server's perspective, the single photo library database includes the structured data in the MDF file, as well as all of the blob data stored in the photos folder that it will create. And once you've created a FILESTREAM enabled database, you can create any number of tables that use FILESTREAM columns. I already indicated that all you need to do is append the FILESTREAM attribute to the var binary max data type. But as it turns out, there is this additional requirement where you need to have in your table a single column of type unique identifier that's decorated with the row grid col attribute that must also be designated as being unique, so you must be quite emphatic about how unique this column is, but SQL Server absolutely requires this column in order to be able to do what it needs to do behind the scenes to manage all of this for us. But once you've defined that column, you can, and you can only have one row grid column, you can then define any number of blob columns as var binary max file stream as you'd like. Okay, any number per table. So let's get started. I'll switch over to Management Studio. I've already enabled FILESTREAM, and I'm just going to go ahead and create my database. I'm just going to point out that this photo library folder already exists and is empty, so we're ready to go. Here, I'll bring that up here. This is my empty photo library folder, and I'll go ahead and create the database, switch back over to the file system, and you can see that in addition to the MDF file and the LDF file that we're all used to seeing get created when we create a new database, SQL Server has also gone ahead and created a Photos folder. Now this Photos folder is off limits to us, just like these files are off limits to us as developers and certainly to our users. This folder should be locked down from a security perspective the same way you lock down your MDF and LDF files. Even though that's the case, though, we are definitely going to peek and even poke a little bit inside that folder as we gain an understanding of how FileStream works behind the scenes. I'll go ahead and use that database and create my photo album table here, which simply has a photo ID for the primary key. There's my unique identifier column. Yeah, that's the data type. That's the attribute. It mustn't tolerate nulls, and it needs to be unique. And all of that is necessary. You must spell it out, or it just won't work. But as it turns out, even though we have to have this column, by saying that the default value of that column is the next available GUID or the next available unique identifier, we don't have to actually do any work to maintain this column. When we insert rows into this table and don't provide a value for row ID, we'll just get the next available GUID automatically by default. That's the description of the photo, and this is the photo itself, the blob, that just with the var binary max data type would be storing it in the database, but by appending the FileStream attribute, it gets stored outside the database. And let's not talk yet about what appears to be a default value of a zero-length binary stream. That will come into play in part 2. Just going to go ahead and create the table. And we're progressing here incrementally. So we want to first do something very simple and very contrived and monitor the effects on the NTFS file system as SQL Server carries out our FileStream activities. So I'm going to insert my first row into the photo album table. What looks like a direct insert into that photo column, I'm just casting some text as var binary max, but it certainly appears to be being inserted as a single row, and when I select that row back out along with the length of the photo as well as a cast back to varchar so that we can read that text, it certainly appears to come back out that way, right? There's our binary data. It looks like it's in line. Somewhat anticlimactic, but that's kind of the way the powerful abstraction layers are. The whole idea is that it's supposed to be transparent. Everything looks like it did before, but if we peek behind the scenes, that's where we see things happening that make FileStream usable as this kind of abstraction layer. I'll go into the Photos folder, which you're not supposed to do, and I'm going to go and cast my Windows 7 security prompt there. And again, you're not supposed to be in here, so it's none of our business to know or understand how SQL Server has decided to go ahead and create these subfolders with these weird names, but we can still be curious and we can still dig in. And if I dig in far enough, I will come across this file, which if I open it in Notepad, you can see contains the text BLOB. And just to prove the point here, I'm going to actually go ahead and modify this text, put my name in there, and then hit F5, which timestamps it, so you know I've got nothing up my sleeves. It's 1:17 p.m. on 8/19. Save that file back out to the file system, switch back to Management Studio, and when I select that row right back out now, you can see the binary data has changed. It's now 23 rather than simply the 4 characters. If I cast it back, there's proof positive that the change made in the file system is reflected transparently. So that's quite impressive so far, but it gets much better. I'm just going to do another insert that's a little bit more realistic. If I have a small amount of binary data, you can just inline it directly as I've done right here. And I'll just insert our second image and switch back over to the file system. There's another file, which if I open with, let's say, Photo Viewer and magnify that for you, that is the pixel by pixel rendering of the binary blob that I stored in the second row. All right, so that's pretty powerful in and of itself. But things actually get a lot better. Actually, let me just switch over to Management Studio and select both of those rows back out, and you can see the second row has a very lengthy blob. Well, not too lengthy. If it gets lengthier than that, it's certainly going to be awkward and contorted to do that in T-SQL. You can certainly continue to embed and extract byte arrays as you've done in the past, but if you're using FileStream and you want to gain the maximum performance, you're definitely going to want to use what I'm calling part 2 of FileStream, which is called SQL FileStream. Let me switch back to the slide deck here. And as I indicated, it's not always practical or easy to manipulate blobs with T-SQL. You can continue to embed and extract byte arrays, but the most performant way of getting data into and out of the file system is how? Well, certainly interacting directly with the file system, which is a native environment optimized for streaming. The database environment is not optimized for streaming, and if you just go directly against the var binary max data type, there are some layers that you have to go through, that the data has to go through, which slows things down. If you want to stream directly into and out of the file system, there's this new feature called Open SQL FileStream, whereby SQL Server will, just at the point in time when you want to store or retrieve blob data, SQL Server will step aside and allow you to gain a handle onto the file, on the file system, so that you can read and write directly to that file system using the FileStream class in .NET. This can also be done in native code with the Win32 API, read file and write file, but we're just going to focus on .NET. So here's the recipe. You begin by starting a transaction. You can't use this feature if you don't use transactions. This is true even for reading data. So be aware of that. You are using a transaction even when you're reading data. You'll either insert or select a row, and at that point in time, when you've inserted the row, you've inserted everything into the row except the blob data, and because the transaction has begun, that row has not yet been committed, and you then have to retrieve these two key pieces of information, and I have them highlighted in blue. You'll see them in our demo. One is a logical path name. That's not a physical path name, so you're not exposing anything that you need to be worried about from a security standpoint. It's just a kind of bogus path name that SQL Server knows how to map to the real file, as well as the context, some handle onto the current transaction. And when you get those two key pieces of information, you pass them as inputs to SQL FileStream. You get back a handle, and you're good to go. You update your file, and only when you commit the transaction will the row in the table and the file in the file system both get committed at the same time. Let's take a look. All right, I'm going to switch back to Visual Studio. Here's my photo, my little photo application. The first part of the form allows you to save a new photo into the database, and the bottom will let you retrieve it and display it. I'm going to try to walk through the code as quickly as possible and then run the demo and then move on. So up in the UI, once I've gotten the photo ID description and file name, I call into my data access layer. And what I'm going to do is, I usually like to single step through this code, but since I'm using implicit transactions with transaction scope, I have found that it just times out and just doesn't make for good demos. So I'm going to walk through the code here. I will set a breakpoint at one place and hopefully not pause too long so that we don't break the demo. But you can see that I've got an insert statement here that inserts just the photo ID and the description, but does not include the blob itself. And that's where that default length, that default value of the zero-length binary stream comes into play. If I don't provide a value, it's going to use a zero-length stream. Think of it conceptually as the same difference between a zero-length string and a null string in .NET. The two are not the same. Similarly, you won't be able to use SQL FileStream against a null instance of the FileStream column. You'll need a zero-length binary stream to first be sent out to SQL Server before you'll be able to use SQL FileStream. All right, so start my transaction scope. I start my connection. I set up my command, and I invoke execute non-query. At this point in time, the row has been added but not committed to the table, and we have an empty file in the file system because of the zero-length binary stream. an empty file in the file system that has not yet been committed, we call into save photo file. And you'll see that this method doesn't do anything magical. There's nothing special about this method. It follows the standard pattern for copying from an input stream to an output stream, in this case in 512K chunks at a time. You can see that I open a source stream and a destination stream and simply read from the source and write to the destination. We've seen code like this lots of times, right? Nothing special here. Gaining a handle onto the source stream is also a no-brainer. The file is local, so we simply instantiate a new file stream object and pass these parameters into the constructor to get that handle. The question/challenge here is gaining the handle to the output file, the destination file stream. How do we get the handle to the target SQL Server file stream managed file system? And that is done by calling it to get output SQL file stream, where I have the photo ID. Now, what I'm doing is I'm selecting back the same row that I just wrote that hasn't been committed. No one else can read this row because it hasn't been committed, and that would be a dirty read. If this transaction never commits, this row will actually never be come into existence. But we're inside the transaction. We can read it back. We can get those two key pieces of information that I mentioned on the slide, the logical path name and the file stream transaction context. I will set a breakpoint on this line of code here. Hopefully it won't break our demo, but I do want you to see what those values look like. And once we have those two values, we can create a new SQL file stream object, passing in those two values and indicating that we want to write to this file stream, and that's how we get the handle. So let's just go ahead and give it a run. And I've already inserted two rows in Management Studio, so this will be row number 3. My local file is named c:\ascent.jpg, and it's a picture of mountains. And I'll click Save. We will hit my breakpoint. We're inside the transaction. We should hit that breakpoint. Look at the value of the file path. You can see inside there the DBO is the database, the schema name and the table name. It's just, there's no physical file path information being exposed. The transaction token doesn't mean anything to us, but it is a meaningful handle on to the current transaction. I'll let it continue before it breaks. And it looks like it went through the whole way. If I switch back to Management Studio and select back out all 3 rows, you'll see, yeah, there's the 3rd row. This was added using SQL FileStream, and it's a 63K image. And that's really the way to get data into and out of a var binary max FileStream column. That's the proper way, as I like to say. And we would be done, right, except we would like to see this come back. So very quickly to look at the select photo, and I want to retrieve that back out. It's a very similar pattern. It might seem a little strange to use a transaction when all you're doing is reading. You normally try to keep your reads outside of transactions as a best practice. But to implement this particular pattern, this is exactly what you do. You start the transaction, you open the connection. Here I am selecting the description, but I'm not selecting the blob. Instead of selecting the blob, I'm selecting just the 2 key pieces of information that I'll need to get that blob much more performantly, as we just saw, the file path and the transaction token. Only this time, since I'm streaming back an image object that's going to be bound to the picture property of the image box control in the UI, you'll see there's no looping. It's very powerful capability here of the static from stream method on the image class will consume this entire stream into an image object directly bound to the picture box control on my form. So when we give that demo a run and we retrieve that picture number 3, there you have it. Now I've got more demos, just not enough time to show them. I did want to mention that all of this demo code is going to be available to you. There I have other demos that show how this works with ASP.NET, how you can set up an HTTP service to stream this directly from the file system over HTTP's response stream in ASP.NET, as well as how to consume that in a WPF client. The crux of the data access is no different than what I've shown, so it is nice to see it applied to other platforms, but it's no different than the pattern that we've seen so far. So with that, we're going to conclude our demos on FileStream. We're going to revisit FileStream a little bit in our Geospatial demo, but for now, that does conclude the FileStream portion of this webcast, and I will pause for a moment now and see if Mary has queued up any questions for me. We have about 2 or 3 minutes that I might be able to take some of your questions on FileStream.
Hi, Lenny. We do have a couple questions that came through.
Sure.
Itai says, How much disk fragmentation impact overall query performance when retrieving the blob?
Well, that's a good question, and you really need to think of this as being in the file system. And if you were doing this yourself, you would not want to populate you would not want to populate a single directory with every file. It will reach a point where the performance will suffer. And to a great extent, we are putting our faith and our trust in SQL Server to manage things performantly and to partition that subdirectory into further subdirectories for maximum performance. Otherwise, it's just file system access. How badly fragmented is your file system is directly relevant to the performance hit that you'll take when retrieving these blobs. I'll also, that does remind me of another point that I forgot to mention that's nice for SQL Express users, that blob data stored in the file system because of the FILESTREAM attribute does not contribute to the database size vis-a-vis the maximum database size that's allowed in SQL Express, which has been 4 gigabytes until now, and only recently with SQL 2008 R2 has been increased to 10 gigabytes. If you've got lots of blobs and you store them in the file system using FILESTREAM, they don't count against that maximum limit.
Great, thanks. One more question from Matai. He says, what is the protocol overhead for such native RW?
I beg your pardon?
What is the protocol overhead for such native RW?
I'm afraid I don't understand the question. RW as in read write. Again, that's all being done at the file system
read
level.
write. That's what
Right.
he said.
So all the reads and the writes are done at the file system level. So I'm not quite sure what else Ty's trying to get at here.
Okay, well, the last question I have, maybe he'll respond in the chat room a little bit. He says, are there any benchmarks on style, a number of blobs, access times, etc.?
Yeah, you can dig to find that. I myself have not done too much benchmarking, too much performance testing. I have personally used this in production successfully against fairly large websites and haven't had the need to performance tune. So there's certainly information out there available on performance.
All right, great. He responded in the chat room and said, regarding the protocol overhead question, from the client to the server via the API.
Yes. So again, there's only standard file I/O activities. There's no if you were just writing your own either native code or a managed code application and opened a handle to a file across the network, it's the same API. So I hope that answers your question. If not, we can certainly take it offline and shoot me an email. I will get you an answer if I'm able and find out an answer for you if I'm not.
Great, thanks. Adam was asking, can documents stored via FS with appropriate I filters be indexed with FTS? Well,
that really, that's not something I can answer directly here. I know that in addition to the native file system, we have, there is support for remote blob storage devices that have their own unique interfaces, but I've not explored that in depth. So certainly shoot me an email on that and we can explore that further. I think we need to advance on to part 2 as I see we're past 1:30. Right?
That sounds good. Go right ahead. Thanks.
Yeah. All right. So with the introduction of SQL Server 2008, we finally get support for geospatial data types. That is, data types that are aware of space, distance, area, length, that sort of thing. And this has very strong implications, of course, for GIS applications or geographical information systems, such as GPS systems, and so on. And this is a capability that Oracle has had for a while. SQL Server now supports it. And we get 2 models that we generally work with when we're dealing with geospatial. One is the Planar model, and one is the Geodetic model. The Planar model is also known as the flat Earth model. It is what you use when you're dealing with surfaces that are either conceptually flat, such as, for example, a building floor plan, or even small areas of the Earth where the curvature of the Earth is not significant enough to impact distance calculations. Of course, if you're dealing with much larger regions of the Earth, when you take the globe of the Earth and you flatten it, as we see on this diagram, we stretch and skew the surface of the Earth such that, for example, if I drew a straight line on this map from New York to Paris, in actuality, that line would be represented by being stretched and curved against the shape of the globe. And in fact, depending on how you, there are a number of different ways that you can flatten the Earth into a planar model. This is an example based on the Mercator projection. We might see another example that stretches and skews ever so slightly differently, so it's definitely not going to give us accurate distance calculations across large sections of the Earth. If we need that, then our application definitely needs to adopt the popularly held belief that the world is in fact round and use the geodetic spatial model. All of our coordinates when we're working with this model are strictly latitude and longitude. We're working with the planar model, just back up, this is an arbitrary coordinate system. X and Y could be inches, feet, meters, anything that makes sense for your application. And to work with these new models, it shouldn't come as a surprise that we get two new data types, one for each model, and we get these two new system CLR types. These are common language runtime types inside of SQL Server 2008. One is called geometry, one is called geography. Geometry is for the planar model, geography is for the geodetic model, but the good news is that once you have decided and selected the one that makes the most sense for your application, there's a tremendous amount of overlap. There are almost, believe it or not, 70 methods available on these types, and most of those work identically for geometry and geography. Right? So when we are working with these geospatial types, we express our shapes using, well, one of any number of ways, but WKT is one way. The simplest way is a simple markup language. Here I have some examples. You can see it's just a simple point, or perhaps a line string where there are several points that plot the line, a polygon that identifies all of the sides of a shape or of a closed shape. You can have a geometry collection. The example on the bottom there shows a collection that includes both a point and a line string. You can see examples here that are using arbitrary coordinates, like the first one, 0.610, that could be 6 across, 10 down, by inches, feet, meters, what have you. You see other examples that are using latitudes and longitudes. There are a number of ways to get, I mentioned that WKT is the simplest one. There's also GML, which is a geographic markup language. It's a little more verbose, but it uses XML to represent geolocations, latitudes and longitudes, but we're just going to look at WKT. Here's an example of how you get a string into a geography data type using the parse method of the geography data type. And let's get started with some simple demos. Our first demo is going to work with the geometry type, and we have a town here that very conveniently has 4 perfectly shaped squared districts, and they're all the same size, and they're aligned in this fashion, and we have these 2 roads running through them, Beach Street and First Avenue. This is a small one-horse town. Curvature of the Earth bears no impact, so we're going to use the geometry data type to just get started with these concepts. And what we want to do is populate this data into a database and query for which streets run through which districts, etc. So let's switch over to Management Studio. Open up my script file for Geospatial. And you'll notice the use of the new geometry data type in both the district and the streets tables. And what we're doing here is storing the districts in the district table and the streets in the streets table. No rocket science there. And you can see I'm using the parse method to convert WKT into a native geometry data type. The polygons represent the districts, the 3 districts, and the line strings represent the First Avenue and Beach Street. And now what I want to do is find out which streets intersect which districts, and I can find that out by using the ST-intersects method. And almost all of the spatial type methods begin with ST, except for those few where Microsoft has deviated from the standard established by the Open Geospatial Consortium, the OGC, the standards body that's kind of in charge of keeping these things standardized. Right? So by invoking the ST-intersects method on one instance of a geometry data type, passing in as a parameter another instance of a geometry data type, that will return a value of 1 for true or 0 for false if those 2 shapes intersect or overlap, if you will. And so by running this query, I will get a response. And what I'm doing is I'm cross-joining districts with streets, right? So that's going to give me every permutation, every possible combination of districts and streets. But in this where clause, we're going to filter out those where there is no intersection. So we saw on our chart that Beach Street runs through all these 3 districts, but First Avenue does not run through Green Park, and therefore it's excluded from our results. But we can do more than just tell if two shapes overlap or intersect. We can actually have SQL Server instantiate a new instance of a new type. Here it is. That is based on the area of overlap. So if I want to also find out what the fragments of each road in each district are, I can say include as another column in my select to give me an intersection column that is the result of passing in one geometry type as a parameter to the intersection method invoked on another geometry type. And if they overlap, a new shape will be created that represents the area of overlap and returned as this intersection column. And there you have it. These are the portions. This is the portion of Beach Street that runs through downtown, the portion of the same street that runs through Green Park. The reason we're seeing it as WKT is because after we ran the intersection method, which instantiates a new geometry type, we invoke the toString method on it, and that will convert from geometry to WKT. All right, let's get a little more real world. Here I've got a map of this is a race that is actually held every year in Philadelphia. And now, some of you may be asking, how do I get my hands on these latitudes and longitudes? Here I've defined polygons for the race area, which is the all-encompassing black-bordered area, as well as the small wall area to the north and the parkway area to the south, which is where spectators tend to gather and take pictures. And in this application, we want to allow people to submit pictures, and included with their picture is the location where they were when they took that picture, and provide an application that allows users to search for pictures taken in particular regions. So how did I get these latitudes and longitudes? Well, there are a number of ways. I mean, you can just go on the internet and get it's public domain information, latitude and longitude coordinates for virtually every well-known location on Earth, certainly all major cities and any zip code in the US, etc. The old-fashioned way still works, so pilots can still get them from sectional maps. In this, excuse me. In this particular case, I use Microsoft Streets and Trips, which lets you point with a mouse cursor over a map and click away and feed you the latitude and longitude coordinates. All right, so let's switch back over to the database, and we're going to combine this, right, the theme being beyond relational, we're going to combine this with the FILESTREAM demos that we just saw, right, because the photos that people take that are geo-stamped, geolocation aware, where we know the latitude and longitude of those pictures, the pictures themselves will be stored as var binary max file stream columns. So I'll go ahead and create the database. Nothing new here. It should still be pretty fresh in your mind from our last demo about this file group contains file stream clause. I'll go ahead and use the database and populate the tables. This is the event region table. We know that it has three shapes. One is the two smaller areas where spectators are going to take their pictures, and the all-encompassing event region area. And now let's select those back out. And you'll notice a couple of things. First of all, you might have even noticed in our earlier demo that which had simple square-shaped districts with only a polygon with only 4 sides. You might have noticed that these binary values being stored in the column are very large, and they can grow very large. And Microsoft, why won't that go away? Thank you. Microsoft had to raise the limit on SQL CLR user-defined data types, since now they're using it themselves. So the previous limit of, I think it was 8K or 4K, whatever it was, it's now 2 gigabytes, something extremely large. So we have no problem storing our large binary objects in these columns. But now take a look at the Spatial Result tab. This is new. You might almost miss it. We're accustomed to only seeing text data come out of our results inside of Management Studio, and for the first time we're actually able to get graphical results. When Management Studio detects that geospatial data is being returned in the query that it is executed, it will include the Spatial Results tab and graphically, give you the picture that's worth 1,000 words, including color coding for overlapping regions. And this is a flat Earth projection. Remember I was saying about how the Mercator projection will give you a slightly different skew. You see, so that's kind of cool. I like that. Let's look at some more methods that we have. ST area and ST length. Yeah, that's going to give me the area and the length, as you might expect. Rounded to 2 decimal places. And let's go ahead. And we'll order by area, so that the descending, so the largest area will be first, and that's the area, and that's the length. And unit of measurement here is meters. Now, how do you know that it's meters? Well, as it turns out, we work with one of any number of spatial reference IDs, and we have the system catalog view here called Spatial Reference Systems, and if you select from it, you'll see that there's a whole bunch that are supported. By default, we are working with 4326. That's the default spatial reference ID, and if I select just that one and scroll over, you'll see that the unit of measurement is indeed meter. Interesting to note the way that's spelled as well, right? So if you're just curious about what other non-meter measurements there are available in that spatial references catalog view, we'll just query where unit of measure is not equal to meter, and always thought this was kind of interesting. You've got other variations here of Clark's foot and Indian foot, which are just ever so slightly off from one another. And we've got also the German legal meter here, which is slightly larger, ever so slightly larger than everybody else's. Right? So we're working with meters. And now what I'm going to do is create another table that's going to store the photos. And you may be aware that you can get attachments for older cameras that don't have GPS capabilities. There are attachments that you can get to, in addition to stamping the date and time for that JPEG image, that when you snap that photo, it will also geolocate that photo. But for our demo, of course, I'm just hard-coding latitudes and longitudes for these photos, and this is a table that's going to store the photos. There's the required row grid column. There's the var binary max file stream column with the default value of a zero-length binary stream. We're also going to get more realistic with respect to best practices and use stored procedures, where in our earlier demo, we were just doing everything with direct SQL. So when the user starts the application, they're going to get a list of regions that they're going to be able to select from. They want to see all the pictures in a particular region. They're going to need a list. This stored procedure will provide that list for the drop-down. The user will then pick a region, and we're going to want to then query for all of the photos taken in that region. Well, once they've selected a region we know what the region ID is, we get the shape of that region by the region ID, and then we select all photos where the location of that photo intersects the region that the user requested. The same intersects method that we saw working for the geometry type works no differently than for the geography data type. Go ahead and create that stored procedure. At that point, the user has a list of all the photos taken in that region. They click on one and they want to see it. And so here's the same SQL we saw in our earlier demo that was using direct SQL, but in a stored procedure, which is better. Right? Better practice. We get the path name and the FileStream transaction context so that we can call SQL FileStream. At this point, I will switch over to Visual Studio and over to the other project that we have for this demo and populate the 4 photos. I'm going to run through the code quickly because it should really be fresh in your mind from our earlier demo just a moment ago how this works. The only difference now is that we're also including latitudes and longitudes. So this is the photo ID, the description, the latitude and longitude, and the location of the image locally that's going to get stored to the database using SQL FileStream. If we look at the insert event photo method itself, this insert statement looks the same as it did before, inserting everything but not the blob, but also storing the location, which is going to get passed in as a WKT string of the latitude and the longitude that get passed in here. Otherwise, it's the same thing we saw before. We add the row to the table. We call save photo file to stream the photo using this loop to the database, and that's how the photos get populated. So let's run that. Look at photos. Now that the photos have been populated, switch back over to Management Studio, run a couple of more interesting queries, okay? Like this one. Distance. I want to know the distance between these photos. Now, I don't need to, what I'm doing here is kind of a clever way of eliminating needless or duplicate results because I really want to know the distance from any photo to any other photo. But the distance from photo 1 to photo 2 is the same as the distance from photo 2 to photo 1. So I want that duplicate result eliminated. Similarly, the distance from any photo to itself will always be 0. So what I've done here is I am selecting from the event photo table twice. Once aliased as P1, then joined against itself a second time as P2, on the first instance's photo ID being less than the second instance's photo ID, and that effectively filters out, right? I know the distance from photo 1 to photo 2 is 8.46 kilometers. I don't need to return as well the distance from photo 2 to photo 1, and also the distance from the photo 2 itself has also been eliminated. The way this was converted to kilometers was simply by dividing meters by 1,000. And if you wanted to convert this to miles, it's very easy to do as well. There's some multiplier there that you apply, and that'll convert it to miles for you. Area and length we've seen. I see that we're starting to run low on time here, so I want to pick up the pace just a little bit and just switch back over to the demo and finish running through. This is the drop-down list of the various regions. The Parkway area, I click Find Photos. I get the 2 photos taken in that area by the intersects method, giving me just those 2 photos. FILESTREAM returning the photos the way we saw in our earlier demo. If I'm interested in another region, the wall area, here are 2 photos taken in that area, 2 different photos. So as we would expect, the race area, which encompasses those 2 areas, should include all 4, and indeed it does. And that works just fine. I do want to finish this off with one more demo, even though I see that we are running slightly over on time. This is a mashup, if you will, a virtual Earth mashup, now actually known as Bing Maps. The API still refers to it as virtual Earth. I'm going to keep the demo very simple. From the database perspective, it's going to be ridiculously simple. I'm just going to create a customer table, which I hope doesn't exist from before, great, and insert into that customer table all of my customers as well as their locations on the planet Earth, and create a stored procedure. For simplicity, it doesn't take any parameters, and it just returns all of my customers with their locations. Now I'm going to switch over to Visual Studio, and where you'll see I've got a project here set up. I've got my a customer class, just properties for the name, company, latitude, and longitude. My own web service running that, if I view the code, you can see it's a simple web service. It's just decorated with the web method attribute. That's what makes it a web service. And the only interesting thing to point out here is the use of Microsoft SQL-Server.types. This is the assembly that houses the SQL CLR types, geography and geometry, as well as hierarchyid, that is our next and final topic. And the only interesting thing there to note that when I do get when I get the latitude and the longitude values from the database, when I get the geography data type value back from the database and I cast it as a SQL geography data type, there's a lat and a longe property on it that I can pluck out the latitude and the longitude from my customer object. Otherwise, there's nothing interesting there. All the interesting stuff happens inside the web page itself. It's a small page, but there's a lot going on, so let's try to pay attention and see how all the pieces fit together. This is an AJAX-enabled web page, so there are no postbacks. Everything happens asynchronously. There are no postbacks. There's no code behind. And every AJAX-enabled web page does require a script manager, and you can see I've got one defined here with 2 service references. One to my own web service that we just saw that will return all of the customers, as well as another service reference to Bing Maps or Virtual Earth Maps API. I've then got a div that is sized to the rectangular area of the page where I would like the map to render, and I've got a client-side button. This is not run at equals server or anything like that. There's no postback, as I said. Instead, when the user clicks the button, we get a client-side JavaScript event handler that fires, which we'll look at in a moment. We've got a page-level map variable. When the page loads, assuming we have internet connectivity, which I believe I do, this will be a recognized type, a virtual Earth map, the name of the div where the map should be loaded into. The user, and that means that the map will render as soon as the page loads. But when the user clicks the Get Customers button, we'll make the call into our own web service that retrieves all of our customers. It's asynchronous, so we have a callback here. All of the serialization and deserialization happens for us automatically behind the scenes. We don't have to worry about it. It just works. When the callback comes back, we get these results that we know is an array, or collection, if you will, of customer objects, each one of which has a latitude, longitude, company, and name property that we can pluck out to put pushpin shapes on our map and set the title and the description of each one. Whew, that sounded like a lot. Let's see if it all ties together when we run the demo. And it looks like it's working just fine. There's our map that rendered on page load. I'll go ahead and click Get Customers, and there are our shapes that came from our database, and this is known as a mashup. And you are, of course, delivering full Bing maps to the user. So that includes zooming and panning and satellite view, and you can drop bombs on your customer if you're so inclined. It's all good. And with that, I'll turn it over to questions. We only have about 2 to 3 minutes of questions if we want to get through hierarchy ID and finish by 2:15. So I'll turn it over to you, Mary.
Great, thanks. That was really interesting. We have a couple questions from Henry. The first one, he says, if accuracy is not important for my use case, is Planar model much more efficient in space and speed for searching K nearest?
Yeah, I mean, it's certainly, if you do not, geometry is going to be more performant than geography because it doesn't have to account for the curvature of the globe. And could you repeat the question? There was a second part to that question?
Sure. He says
no, I'm kidding. Right, and certainly if you don't need that extra calculation, you should use the geometry data type.
Great. So then he follows up, and this might be what you just said, but I'm not sure. He says, if it is more efficient and my input is longitude and latitude from GPS, can SQL Server convert into the Planar model?
That's a great question, and the answer, I'm happy to say, is yes. You can use latitudes and longitudes in your WKT expressions when you're working with the flat Earth model and the geometry data type. But of course, as you would expect, you will those calculations will become more and more inaccurate as they span larger and larger portions of the globe.
Great. And then another question from Henry. He says, is the proper K nearest neighbors SQL query available officially from Microsoft? He says, research indicates that the simple top X order by ST distance DESC does not make use of index and inefficient.
Well, I can't speak to that directly. Certainly, we can follow up on that offline. I do know, and I didn't have enough time to get into this during our demos, but there is sophisticated spatial indexing algorithms in place. It's a multi-level hierarchical indexing scheme where each level subdivides the level beneath it in order to gain the most efficiency possible out of your queries. Whether that index is not going to be leveraged for certain ST distance queries or not is something I am not aware of.
All right. Eric asks, in .NET, is there an equivalent data type to geography or geometry?
Yeah, we just saw it. We saw that's why that's why we have that assembly. So it is a system CLR type, and CLR means .NET, right? So that the same assembly that's running on the server that's managing the type in the database is available to your project. Maybe I should have shown that here in the reference. There it is. So I set that same reference, and that makes the type available in .NET, and therefore I have access to all of the methods, and where was that? There, all of the methods and properties, in this case the lat and the longe properties I'm using, as I mentioned before, but also ST distance, all of those methods are available in your .NET application as well. Great question. I think we're, well, maybe one more.
All right. Adam asked, does Lenny have any suggestions for how to go about mapping street addresses to latitude and longitude to map or geocode as you demoed?
I have thoughts on that. Not enough time to dig into those thoughts, so why don't you try me offline? The distance queries certainly that we looked at, obviously, as the crow flies, these are straight lines. When you're talking about GPS for directions, there's a whole nother element there. Geospatial capabilities are very complex. Those calculations internally are very complex, as you might imagine. But the idea here is to abstract that complexity away from us so that it doesn't require a deep understanding of geospatial in order to work with these types. We just have to be able to reach as far back as perhaps high school and remember, what a polygon is, and that should be good enough for us to at least get started with these types. I'll also mention another point that I forgot to when we were running through the demos. Elevation. This is a question that comes up a lot. Elevation, although you can store elevation as a third value in your spatial entities, they do not get considered in spatial calculations. So even though the curvature of the Earth is being taken into account, If I'm driving and there's a mountain between me and you, it's going to take a lot longer if I have to climb over that mountain. And those, I guess we can look forward to the next version of SQL Server adding that support. Okay, I think we need to move on to our third and final topic with only 15 minutes remaining.
Great, thanks, Lenny.
Sure thing, Mary. Hierarchy ID. So hierarchical data is not relational, right? It's stored as a collection of nodes, parents, children, grandchildren, cousins, etc. And when we think of hierarchical data, one of the first things that comes to mind is XML. That's the most common form of hierarchical data that we encounter in today's world. And certainly, we have XML support in SQL Server 2008. It was introduced in 2005. There are debates as to whether it's a good idea to store XML in your database. There are many people who feel that while XML is a transport mechanism, which is great for passing data across the wire, it's not a storage mechanism, and it should be normalized into relational tables. There are other people that have a more have the other extreme view that think they can do everything with XML and XPath and XQuery, and they don't even and they think the age of the database is over. Reality, as usual, is somewhere in between, and I'm not here to solve that, to resolve that debate. I'm here to show you that there's an alternative that you can use now with SQL Server 2008 if you don't want to go all the way, because you are going all the way if you go with XML. If you store your data in an XML column, all of the attributes and elements are stored as attributes and elements inside of a single blob column, if that's not what you want. If you want to continue storing your data as rows and columns, but you just want to cast a hierarchical structure over that table, the hierarchy ID data type new in SQL 08 is what you use. And to be clear, these are the types of hierarchies we're talking about, right? Hierarchies that grow deep and wide indefinitely. Here are many different examples, but the common theme across all of them is that they're all hierarchical in nature, and they're all typically iterated recursively. Now, this, too, is not a new problem, and we've certainly dealt with this in the past, and the traditional way of dealing with this is with the self-join approach of a single table. The classic example is the employee organizational chart, where each row in the table represents an employee with their own unique ID as the primary key, but that row also holds a foreign key to another row elsewhere in the same table of that employee's manager. And in that row, again, that row will have a foreign key to its manager all the way up to the root, and in that way define your hierarchy. And that certainly works, and common table expressions that were introduced in SQL Server 2005 gave us recursive queries that made it even easier to execute queries against a self-joining hierarchical table, but there's still a lot to be desired. It can be actually quite difficult to implement more complex queries than that. You're certainly on your own when it comes to updates. It can be very complex if you want to reparent, let's say, an entire node with all of its children to another location in the hierarchy. It can involve complex transactions. It can involve a lot of work on your part. And hierarchy ID is a new data type that has been provided in SQL Server 2008 to simplify this. Now, I'm going to point out that there are two parts to this. The first part is populating the hierarchy, and that is not without a little bit of pain. And you might look at the demos and say, well, you know, it looks like a bit of effort to get my hierarchy populated. And there's truth to that, but the big payoff comes after that point in part two when you're actually querying and manipulating this hierarchy. So let's be clear here that that SQL Server itself isn't doing anything special, isn't doing anything magical to your table. There isn't anything special about your table other than the presence of a column of the hierarchy ID type. So what SQL Server is giving you is a data type with methods on that data type that you can use to implement the hierarchy yourself. This is important to understand. It takes a little while to get used to it, but you are managing the hierarchy yourself. And each value in a hierarchy ID column contains, embedded in the bits there, the exact path to that node's location in the hierarchy, all the way from the root to that node, down to the actual ordinal position of that sibling amongst other siblings beneath the same parent. I mean, that's how precise you can get. And once things are populated, it's very easy for you to query and manipulate the hierarchy. Reparenting is very simple, and we're going to see that in our demos, which are going to cover all of these methods. I'm not going to spend time now going through them since you're going to see all of them in action in our demos. So let's get started with our demo, which is going to work with this hierarchy as an example. We can see Dave at the root. Now, when you look at this illustration, you can see the numbers that we have in bold after each name. Those are the primary keys that we've assigned for our benefit, so that Amy, for example, her ID is always 46, regardless of her location within the hierarchy. It's important to understand that SQL Server does not require any unique value other than the hierarchy ID value itself to give you this support. And the / delimited values that you see beneath the names, those are the human readable representations of that binary encoded hierarchy ID value. And you can see that just, the number of slashes represents the level, how deep you've gone, and the values in the slashes indicate parent relationships and sibling relationships. If you look at the bottom, you can see Jeff comes after Richard because he's got a 2 at the end instead of a 1. Okay, so let's switch over to Management Studio and bring up my last script here. This is the same hierarchy, and what we've got here is a table. There's the node ID column. You can see the data type is primary, is hierarchy ID, and we are also making it the primary key. You don't have to. I've chosen to. And by doing so, or even just by giving it a regular index and not making it the primary key, you get what's called a depth first index, which makes querying against your hierarchy very fast if there are many, many levels that run very, very deep. Later on, we'll see how to create something known as a breadth first index, which will enable very fast queries against hierarchies that grow very wide. That is, there are many, many siblings at each level. So the next column you'll see is the node level column, which is a calculated column defined as the return value of the get level method invoked on the node ID. So Dave is at level 0. Amy, John, and Jill are at level 1. These folks are at level 2, and so on. And that's going to return that number. Now, I'm doing this for 2 reasons. One is so that I'd like to be able to see the level. That's not a good enough reason because I could materialize that value on the fly when I do a select, right? I don't need to store the level as a column physically in the table. But for the second reason that I'm about to describe, I do need to do that. If I want a breadth first index, as I was mentioning a moment ago, I need this column here, and you'll see how that comes into play when we create the breadth first index. Otherwise, it's just the employee ID, their name, and their title. Let's go ahead and create that table. And now we're ready to insert the root node, which is Dave as the master parent, if you will. And establishing values for all of his columns is straightforward, except for, the question is, right, how do we establish a suitable value for this hierarchy ID column? For the root, it's a simple answer. There can only be one root, and you get a value by calling the getRoot method. It happens to be 0. When we look at the employee table, you can see it's 0. Its node level is 0. There's only going to be one row here. Now, only the root node has a human-readable representation of this binary node ID. 0, I can tell, is the root. But you'll see that once I start populating children, I won't be able to read that value. Now I want to add Amy, right, as the first child beneath Dave. The way that I do that is I need to determine what a legitimate value will be for her node ID, right? And the way I do that is by invoking the getDescendant method on the manager, on the parent. The parent is Dave, whose employee ID is 6. I get his hierarchy ID value, and the way that I get a value suitable for one of his children is to invoke a getDescendant on him, Dave, and tell SQL Server that I want to generate. This actually doesn't get an existing member. This generates a new value that is suitable as the child of this node, and we'll talk about these 2 values in a moment, and that makes this new node ID, or this new hierarchy ID value, a child of Dave. So what are these 2 parameters that we're passing in? They represent the 2 existing nodes beneath Dave that I want this new node to be sandwiched in between. And since there are no pre-existing nodes yet, I say null and null, which is like saying inserted before the beginning and after the end. It's a little awkward that you have to do this, and that's why you'll see that we're going to create a store procedure to simplify this, especially since in our particular example, we don't care about the ordinal position. It's okay to simply tack them on to the end. I have here an alternative single statement version I broke it out into 2 statements earlier to make it simpler, but you can see this is the same version that uses a nested select to get the parent. This is the nested select to get the parent node Dave on which to invoke the getDescendant method on for Amy's node ID value. Let's select it back. Right there. Now 58 doesn't mean anything to me, but the toString method shows me the /delimited value, and we're at level 1. This is going to be tedious for all the employees that we want to add, so we're going to create a stored procedure to simplify insertions called USP add employee. Anytime you want to add an employee, you call the stored procedure, you provide the primary key of the parent of this new employee and this new employee's ID, name, and title. We'll talk about the meaning of this transaction in a moment, but we'll first look at a new method here called getAncestor. So what we need to do to insert any child is we need to call getDescendant on that child's parent. We can get the parent in easily enough because it's being passed in, right, as a parameter to the stored procedure. That means our challenge is ascertaining the suitable values for these 2 parameters required by getDescendant. We know that since we don't care about the ordinal position, we always want them tacked on to the end, that null will always be the suitable value for the second parameter, and that makes our challenge finding out what value to provide for the first parameter. And that means that if we're adding the first child beneath a parent, like we did for Amy, we would want that to be null if there are no other children. Otherwise, we want that to be the node ID of the last child so that this new child gets added at the end, if you will. Kind of warned you about how it's a little awkward and contorted to get these things populated. The big payoff will come when we query. So let's see a little further here. So when I get the, I have here the manager's node ID, and based on, the primary key was passed in, right? Okay, and then I get the hierarchy ID value for the manager, for the parent, which is a hierarchy ID value, upon which I can invoke a getDescendant. And I want that to get all of the children of this parent because I need to get the last one. So I will select all of the rows whose 1 level up ancestor is this parent. Another way of saying get me all of this parent's children, right? And if there's more than 1, give me the max, which will give me the last one. And if there aren't any, it'll be null. But in any case, it'll be the correct value, right? If there aren't any yet, this will be null, and that's what I want, like we saw for Amy. If otherwise, it'll be the ID of the last child, and that's also what I want. So either way, we're good, and I can just do the insert and simplify my insertions into this hierarchical table. Go ahead and create the store procedure if I haven't already. Great, and now adding the rest of the employees is trivial. Now let's take a look at our hierarchy. That's more like it, and it represents our chart. Some simple querying and some manipulation, and then we'll be done. Here, even though it's certainly easier to read the toString representation than the underlying binary value, it's still not good enough for our users. We want to provide them with a friendly, let's say, breadcrumb-style representation of all of these nodes, and we can do that with this little function here that I've created called getFullDisplayPath. You pass in the hierarchy ID value of the node that you want to get this full display path for, and we invoke the getLevel method. Actually, right, okay, we invoke the getLevel method. We saw that earlier. And the larger that number, the deeper we are, and that's going to drive how many times we iterate our loop, because we have a loop counter that is initialized to 0, and we'll iterate until we reach, right, we're incrementing that counter, until we reach that level of depth, and for each one, we're starting off with the level counter as 0, and we're incrementing it to 1 on the first iteration. So getAncestor, the first time around, gets me the parent. The second time around, this will be a 2, gets me the grandparent, and the great-grandparent, and so on. Each time prepending to the display path, the parent name, and the breadcrumb indicator, which is that greater than sign. Now, did I create this? I can never remember. I hadn't yet. Great. So now when I call this, run this select, which includes a column based on that function, it's going to look a lot better to the users. Right? That looks a lot better, doesn't it? Okay. Now, I'm realizing that my hierarchy is now growing very wide, and I want to improve performance on queries that scan this hierarchy horizontally, if you will. So I'll create a breadth-first index, and the way that's done is by creating a composite index that includes the node ID And the node level column, that calculated column, that's going to give me a breadth first index. Now it's time for some querying. I want to find out who all of Amy's descendants are. Right? Switch over to the diagram. That would be Cheryl, Wanda, Richard, and Jeff. Very easy to do that with the isDescendantOf method. You pass in any node, you pass in the parent that you're interested in, and run it by every node in the entire table, and it will return true for any node that is a descendant, either directly or indirectly, of Amy. And it returns Cheryl, Wanda, Richard, and Jeff. Now, interestingly, it returned Amy herself. This is not a bug. I first thought it was when I first saw this. But it turns out that the isDescendantOf method returns a subtree whose root is the node ID that you passed in. It's a subtree with a single root node that begins with the node that you passed in. So this is working correctly. Get ancestor, we saw that earlier. If I want just Amy's children, it's just where I pass a 1 in, that's how many levels up to go on the getAncestor method, where the one level up ancestor is Amy, who I know is ID 46. Oops, I'm sorry. And there's just Cheryl and Wanda, her children. This can go on. I don't have to belabor the point here, I don't think. If I use 2 for getAncestor, it gives me grandchildren, or cousins, if you will, Cheryl, Wanda, Mary, and Kevin, right here, as grandchildren of Dave and cousins of one another. To end this off, we want to do some manipulation. It will be done, by the way, in under 2 minutes. Let's say now that Wanda no longer reports to Amy, but reports instead to Jill alongside Kevin. Very easy to do that using the getReparented method. I'll go ahead and get the node IDs of the employees that I want to move, that's Wanda, as well as the old parent and the new parent. Once I have those node IDs, it's just a one update statement. The where clause makes sure I'm affecting only the one node that I want to move, but I'm updating its node ID to the result of calling getReparentedValue, passing in the old parent and the new parent, and it will just magically reparent that one row. Go ahead and do that, and look at our hierarchy now, and you can see indeed that she has moved. Wanda is now alongside Kevin beneath Dave and Jill. Now, I know you're asking yourself, what would have happened had Wanda had any siblings? Would they have moved too? No, they wouldn't have. We saw that the where clause in our update statement affected only Wanda, and the result is that we would have a hole in our hierarchy at this point. This too is not a bug. It's something that just you need to manage. Not necessarily a problem to have an orphan in there, but one way for you to address this problem is to make sure that when you reparent a node, you reparent that node along with all of its descendants. So in this next example, let's say that everybody that reports to Amy, that's Cheryl, Richard, and Jeff, no longer report to Amy. Amy's staying where she is, but the people that report beneath her now report to Kevin. And they are being moved now across and down, and we're getting actually deeper than we've ever gotten before, level 4 in our hierarchy if you start counting from 0. Ridiculously simple to implement this query, to write this query using hierarchy ID compared to how you might have to do it before. Again, get the old parent and the new parent, but the where clause in this update includes all of Amy's descendants because we're using the isDescendantOf method that we saw before, which we pointed out will include Amy herself as the root of that hierarchy. We want her excluded from the move, so we're doing that explicitly here by saying and employee ID, even though she's a descendant of herself, she herself should not be moved. I'm going to go ahead and run that query. 3 rows affected in this single update. Now look at our hierarchy, and indeed you can see we've gotten down to level 4. We've never been there before, and all of the nodes moved. Like I said, a little bit more effort up front to get your hierarchy populated with a big payoff when it comes time to querying and manipulating it. And with that, I know we are over by, it looks like 3 minutes. I can turn it, well, we'll turn it over to questions, but I don't want to forget the opportunity to point out, again, my contact information is here. All of the sample code is available from this bit.ly link. You can email me, or you can catch us on Twitter at the hashtag you see below. And on behalf, again, of 26 New York and O'Reilly, I want to thank you for spending this past hour and a quarter with me, and leave it open for any questions that might be remaining on the hierarchy ID data type. Mary?
Great. Thanks so much, Lenny. I really appreciate it. Ryan asks if you can restate which versions of SQL the functionality is in again. He's wondering specifically
Certainly.
if Express is included.
Certainly. What was the last part? If what is included?
Express?
Yes. All editions, all editions, E-D-I-T-I-O-N-S, of SQL Server, including the Express edition, support everything I've shown. You can do everything I've shown with the Express edition, including FileStream, as well as the Geospatial and the hierarchy ID data type, which is good news, right?
Great. And Sean is asking... Oops, sorry.
No, certainly doesn't require R2.
All right, great. So Sean is asking, with hierarchy ID, where is the root if there are cycles?
Where's the root if there are?
Cycles.
Cycles. I'm not sure I understand the question there, but I think it's related to, again, kind of a little confusion that I had surrounding hierarchy ID, and that is, SQL Server isn't really doing anything here, right? We're doing the work. We're imposing a unique constraint on that column, but if we didn't, there would be nothing preventing duplicate node IDs, duplicate hierarchy IDs in a single column. And it's not necessarily a bug, right? Because that could, in and of itself, enable advanced scenarios where you might be housing two hierarchies in a single table. I've not yet come across that, but it certainly is possible. You could have another column that indicates which hierarchy the other column refers to. So you might not actually have any root at all. You might have multiple roots if you're managing multiple hierarchies. It's your job to manage it. I hope that answers your question. If not, you can either try to rephrase it or shoot me an email.
Great. And someone else is asking what I'm thinking might be a similar question. They're asking if there can be multiple roots. Yes, and
that's exactly kind of what I'm trying to say. In this demo that I just ran, you would get a primary key violation because I indicated that I was using the hierarchy ID column as the primary key, but I also mentioned that you don't need to do that. And if you didn't impose a unique constraint on that column, you could have two roots, but unless you also managed some other control over which hierarchy you're dealing with, you're going to have a jumbled hierarchy you won't be able to make sense of.
All right. And then Sean says as well, I wish there was a stored procedure that could take a list with a column for parent, column for child, and would write out a table with this hierarchy ID. Any suggestions?
Yes, your wish is my command. Hopefully we'll have we will hopefully have some webcast in the future that covers T-SQL enhancements, of which there are many, and there's very significant a number of enhancements. The one that's germane to your question is the use of table-valued parameters that will accept, in a single parameter, any number of rows. And if you combine that new capability with the logic that I demonstrated in our store procedure that we wrote by hand, yeah, you have to write it by hand, but it's not really a terribly large amount of code. If you combine those two things, you will have a store procedure that will accept a table that has any number of rows with pointers to the parents and will construct the correct hierarchy ID values on population. It's a great question.
Great. I have one more question about the hierarchy ID from Sven. He says, is hierarchy ID anyhow supported in SSAS?
Good question. I know that many of the other new data types are supported across all APIs and all services, but you're talking now about analysis services, and analysis services has its own notion of what a hierarchy is in terms of attribute hierarchies for your cubes, and I don't believe you're going to find any correlation there. My gut tells me they'll be rather useless in the world of MDX, but I can't. You can't hold me to that without double checking.
All right, and then Bill has a generic question about your book. He says, does the book cover tools for profiling and improving performance of stored procedures and triggers, both using SQL management tools and other tools like Visual Studio and third product tools?
I don't believe that we have a dedicated focus to those topics. It may come up tangentially when surrounding discussions about performance. but we don't actually have a walkthrough of how to performance tune your queries. It's really more of a developer guide that tries to present in a manageable way all of the new features from a developer standpoint that you can leverage in your applications.
Great, thanks. Well, I think we're out of questions.
All right, and only over by 10 minutes. So thank you again for sticking it out to the end, those of you that have.
Great. I want to thank you once again as well, Lenny, for the great presentation. I think we all got a lot out of it.
Well, I'm really glad. I'm glad you all joined me, and I look forward to the next opportunity to do this again.
Great. Thanks to all our attendees as well. There was a lot of great information shared in the chat room, so thanks everyone for your contribution. As I mentioned before, we'll have a recording of this available shortly. It'll probably take a day or two for us to get that edited and posted, but we'll send you all an email as soon as it's ready. And that's about it. So I will take a few seconds and then close out the meeting. Thanks again for joining us.